Then we have that you have learned in your first year. So, can you tell me what is phase sequence? Phase sequence. We have static phase sequence already have, right? ABC phase sequence, AC phase sequence, positive phase sequence, negative phase sequence. What is phase sequence?
Connections of R by B are called.
Suppose you don't have R by B, it is written 150. Or if it is written 21, 49, 36, that is the phase sequence. What does this mean?
Each of the phase having 120 phase shifts.
Yeah, that's true. You need to have 120 phase shift, right? Phase sequence is the sequence at which the maximum will be occurring between the phases. So if it is a ABC phase sequence, it means that after a phase, B will have the maximum value, but that maximum will occur 120 degree after the A phase. And after 120 degree of that, the maximum will arrive at phase C. So it is just the representation of ABC. If it is not ABC, suppose you have three phases and these phases are denoted by 69, 36 and 45. So the phase sequence should be 69, 36, 45. It means after 69 phase, the maximum will come to 36 and then 45. So now, for our general purpose here, suppose you have three phases. So these are the three phases. Suppose this phase we are denoting at is at V19. Suppose this is my B26. This is my B39. So there is no ABC, right? And it says your phase sequence is B26 to B39 to B90. So what does it mean? First maximum will appear across 26, right? After that the maximum will appear across 39 phase and then it will appear across 90.
So basically 26, 39 and 90 everyone should determine what?
Just numbering.
ABC.
Yeah, just it's the naming, nothing more than that. So basically, what we are used to is suppose this is my BAN, right? This is BPN and this is BCN. So now, what should be your BAN? We can write it as BM sin omega t minus 30 degree. Why I am taking minus 30 degree, I will explain that later. Okay. So what should be my BPN then? If it is ABC phase sequence, it means after A, the maximum will appear at B, right? So it should be Bm sin omega t minus 30 degree minus 120 degree, or we can write it down as Vm sin omega t minus 150 degree. And then your BCM, it should be Vm sin omega t minus 30 degree plus 120 degree, or we can write it down as Vm sin omega t plus 90 degree. Right? So if you put this thing as a reference 0 degree, so your Van it will lag behind the reference point by 30 degree, right? Similarly, your Vbn it should also be Vbn, it should be 30 degree from 180 degree, right? And what should be your Vcn? It should be positive 90 degree, right? So you are considering negative angle to be anti-clockwise direction. So anti-clockwise direction will be the positive angle, right? So what is the relationship between the phase voltage and line voltage? It should be VAB. It should be VAN minus VBN, right? So this is your VAN, that is positive, minus VBN. So minus VBN means it should be in the negative direction, right? What? VAN minus VBN. That should be your VAB. Okay. So now this should be also 30 degree, right? So the resultant voltage VAB, this value should be √3 times of the individual phase value, right? Right? So what should be my magnitude then? √3 Vm sin omega t, and it should lead VAN by how much angle? 30 degree, right? What was the angle for VAN? Make sense? Right? Any question? Any question? So what should be my VBN, VBC? VBC, it should be VBN minus VCN. It should be √3 Vm sin omega t minus 120 degree, right? And what should be your VCA? It should be √3 Em sin omega t plus make sense? So in order to, if you want to have VAB starting from 0, we should have VAN lag behind how much angle? Minus 100 degree, right? But in your Harmonic sheet book, where this reference is given, so actually it's in Harmonic sheet book, page number 99. The hard copy, I don't know the exact page number of the PDF that we provided, but it should be somewhat around 90 to 100 pages. So in the Harmonic sheet book, they say your VAN, it should be Vn sin omega t, not omega t minus 30 degrees. So there is a printing mistake in the Harmonic sheet book. Because if you don't have here omega t minus 30 degree, then here it should not be omega t. It should start from omega t plus 30 degree. If it is omega t, then it should be omega t plus 30 degree. If it is omega t, then it should be omega t minus 30 degree. Make sense? Make sense? Okay. So now, if you understand this, So we will have, I think everybody can see now, we have a three-phase rectifier circuit. Is it controllable or uncontrollable? Controllable or uncontrollable? Why? Because we have diode, right? And diode, whenever its anode voltage is positive with respect to the cathode voltage, it starts operating. It doesn't wait for any other command, right? So that's why it is uncontrolled device. So now, as you can see, your A terminal here, A terminal is connected between which diode? D1 and D4, right?
Sir, can you use those?
Yeah, sure. Clear now? So your diode A terminal is connected between two diodes, right? So A is connected between D1 and D4, right? When D1 will be conducting? When D1 will be conducting? When this terminal becomes positive, right? When D1 will be conducting? When A terminal is positive, right? When D4 will be conducting? When A terminal will be negative as compared to other terminals, right? So whenever D1 is conducting, when D1 will be conducting? When A terminal will be positive as compared to the other terminals, meaning when you have VAB greater than 0 or VAC greater than 0, meaning A is operating at higher potential with respect to B terminals or C terminals. Clear? Similarly, when D4 will be conducting, when D4 will be conducting,
terminal negative.
when
B terminal is positive.
VBA is greater than 0 or VCA is greater than 0, meaning A terminal will be negative as compared to other two terminals. Make sense? Because suppose we are considering VAB, so whenever your VAB is greater than 0, meaning VA is greater than VB, right? So how the current will flow? From this one it will go through like this, and your B terminal, okay, your B terminal is connected where? Here. So your B terminal will be negative, so it will come and go through your B in this direction. Make sense? Sure. As I said, when your VAB is positive, it means your A terminal is positive with respect to B terminals, right? So what will happen? So VAB means A terminal will be positive and the B terminal it should be negative, right? So meaning that suppose you have a VAB and from this A terminal and this is your B terminal. So from A terminal, which diode is connecting? Your D1, right? And from here it will go through D1 and then it will go through the load, right? And then what will happen? It will come through D6, right? So here you will have a diode like this and this should be your D6, right? So this should be your positive terminal, this should be your negative terminal, right? Make sense? So that's what I said, when A is positive with respect to B, D1 will be operating, right? And for example, when BA is positive, BA is positive means what? B is positive with respect to A terminal. So current direction will be exact same or in the reverse direction. Reverse direction, right? So in that case, what will happen? So instead of having this terminal, now what will happen? This terminal will be positive with respect to this terminal, right? Right? So how the current will flow? So from this terminal, it will go through this, then it will come back, and then it should go like this, right? So here it should go like this, all the way here, in this direction, then go like this way it should come back like this. So now, which are the diodes that is operating? D3 and D4, right? D3 and D4, right? So when, that's what I said, when D4 will be operating when A terminal is negative as compared to other terminals, right? Right? When D1 will be operating when A is positive with respect to other terminals. Make sense? Any question? Now similar to that, if I want to get the condition for operation for B, so B is connected between D3 and D6, right? D3 and D6. So when D3 will be operating, when B will be positive as compared to other two terminals, right? So in that case, what will be my condition? VBA should be greater than 0 or VBC should be greater than 0, right? Similarly, when D6 will be operating, so when BAB should be greater than 0 or B should be negative as compared to the other terminals, right? And we have VCB, it should be greater than 0, right? Now, what are the conditions for operation for other two diodes? So now C is connected between which diodes? C is connected between D2 and D5, right? So when D2 will be operating, when C is positive with respect to, D2 will be operating when D2 will be operating when C is negative, right? So C is negative means VAC greater than 0 or VBC greater than 0, and D5 will be operating when C is positive means VCA greater than 0 and VCB greater than 0, right? So based on that, do you understand how we draw the conclusion here? So now if I want to, now here if I draw this waveform, how we can get this waveform? We know simply this waveform. VAN is Vn sin omega t minus 30 degree. VBN is equals to what? Minus 150 degree, and VCN is plus 90 degree, right? So if I subtract VN minus VBN, we'll get VAB, right? And this VAB, it should start from 0 degree, right? So here, as you can see, your VAB is starting from where? 0 degree, right? Then your BBC should be 120 degree behind of that one, right? So this is 60 degree, this is 60 degree here. BBC is starting from. Make sense? And BCA, it should be again 120 degree behind from BC, right? So where is your BBC? Here. So this is starting point, so 60 degree, 60 degree. So here from here, your VCA, it should start. Make sense? But in your book, the equation for VAN was written as Vn sin omega t. It should be Vn sin omega t minus 30 degree. Make sense? So now, here as you can see, for this portion, which part is operating at higher voltage? VCB, right? So whenever VCB is operating, so C is at high potential with respect to B, right? So when C is at high potential, which diode should operate? B5. And when B is negative, which diode should operate? B6, right? So 5 and 6. Here you see 5, 6 operating, right? Now next time, which one is higher? AB. So whenever AB is operating at high potential, so which one should be operating? D1 and D6, right? Here you can see 1 and 6. Make sense? After that, which one is operating at high potential? VAC. So when VAC is at high potential, then D1 and D2 should be operating, right? Here you see 1 and 2 is operating. Make sense? Any confusion so far? Any confusion? So now, as you can see, this point, this portion is represented by this portion. Because from here to here, VCB is operating at higher potential, right? And this entire voltage, it will appear across the output. Make sense? Similarly, for this portion, VAB will be operating at high potential, and this entire voltage, VAB, it will appear across the output, right? So over a period of one cycle, from 0 to 2 pi, how many ripples you will have? 6. Right? Any question regarding this? Now, if I want to draw the line current, suppose FS current we want to draw. So what will be the line current A? So line current is A through the A will be positive whenever your A is operating at high potential, right? So for these two portions, current should be positive, right? Because A is operating at high potential as compared to B and C, right? But for these two portions, A is operating at lower potential, so the current should be negative, right? So whenever A is positive, as you can see, you have a positive current. Whenever A is negative, you have a negative portion of the current, right? Because if you can draw line current A, B and C current will be just 120 degree phase shifted, right? It's a balanced system. Make sense? So if you can draw for one phases, the rest two phases it will be just a phase shifting properties of the A phases, right? The rest of the things, the RMS value, the DC current values, everything will be the same, right? Apart from the phase shift. Make sense? Now, the diode current. Now, if I want to draw the IT1, when D1 will be operating? Only for these two conditions, right? When VAB greater than 0 and VAC greater than 0, right? So we have only these two portions for which there should be a diode current D1, right? Make sense? But here you can see, is A is operating at higher potential or lower potential? So this waveform, it will not be present. There is a mistake in the book. It should not be present in the output. Make sense? Because during that time, your D1, it should be switched off, right? In that case, which diode it will be operating? D4. Right? Make sense? So if you understand the waveform, is there any question regarding the waveform of the rectifier circuit, three-phase rectifier circuit? Any question so far? Any question? No? If you don't have any question, that means two things. Either you have understood everything or you have understood nothing. So which one? Okay. Now, if I want to write down the equation for the average voltage, so how can we do that? Average voltage means what? Total area divided by total length, right? Total area divided by total length, right? So what is the maximum value of this waveform? Root 3 Vm. Why? Because your line voltage operates at root 3 times higher than the phase voltage maximum value, right? Right? So this maximum value, it should be root 3 Vm, right? Now, these all individual ripple thing, they are symmetrical, right? And the area under each ripple same, right? So what should be the VDC then? VDC, if you write down 1 over 2 pi, but between 0 to 2 pi, how many ripples are there? 6. So the average value, it should be 0 to pi by 3, right? Or if you take the middle portion of that one, this portion, this area. Why we are considering this area, I will be addressing that just a few minutes later, okay? So now, if you consider this area, so what is the area under this curve? It should be pi by 3 to 2 pi by 3 multiplied by what? The area equation of the curve, right? So we can write it down as V of omega t multiplied by d omega t. That is the area, right? And we have 6 similar thing within one period, right? So it should be multiplied by 6, right? That should be the average value, right? Or else what we can do? Instead of doing that, what we can write? We can write what is the length between this portion and this portion? Pi by 2 pi by 3 minus pi by 3 should be 1 over pi by 3. That is the length of this waveform, right? And what is the area under this curve? Multiplied by area under the curve, right? So if you can get the area under this curve and then we divide it by the area length, that is 2 pi by 3 minus pi by 3, that should give you pi over 3, right? That should be the average value. Make sense? Now if you can see here, this point where that maximum is happening whenever you have pi by 2, right? So if I redraw this waveform, suppose you have a waveform like this, and this maximum is happening at pi by 2, right? And this maximum value is what? Root 3 Vm, right? So now the starting point of this curve is what? Pi by 3, and the ending point of this curve is 2 pi by 3. And if I take this pi by 2 as my reference point, so this curve is symmetric about the reference point, right? This curve is symmetric about the reference point, right? So now if I get the area under this curve, the total area should be multiplied by 2, right? The total area should be multiplied by 2. So now if this is the maximum value at the starting point or the reference point, what should be the waveform of this curve? Equation of the curve. What should be the waveform of this curve? So we can write 1 over pi by 3 integration, where it is starting from 0 to, if this is my reference point now, so we will consider this point to be 0, right? And from 0 to this, what is the difference between two points here? This is what? 60 degree, this is 90 degree, this is 120 degree. So what is the starting from here to here? What is the difference? 30 degree. So 0 to pi by 6, 30 degree, right? What should be the equation of this curve? Cos omega t, right? Why we are considering cos omega t? Because cos omega t's value is maximum at the reference point, right? Right? Sin omega t's value is 0 at the reference point, right? Or what we can write, since this is my starting point, so in terms of sin omega t, what we can write? It should be sin omega t plus 90 degree. But it should be sin omega t plus 90 degree is what? Cos omega t, right? And we should multiply it by d omega t. So that should be your VDC, but is it the area? It is the half area, right? So it should be multiplied by 2, right? So this equation is given in your book. Okay, so now suppose you have a waveform like this, but your actual waveform is something like that. So this is your reference point, right? So when you have a reference point, that is your reference point, only for cos waveform you have the maximum value at the reference point, right? So that's why we are considering it as a cos wave. Make sense? Any question? Any question? So you know how to do the calculation, right? Similarly, what should be the RMS value then? What should be the RMS value? VRMS. VRMS means root mean square, right? Root mean square means you have to take a root, then you have to do the mean value square, right? So it should be 1 over pi by 3, but the area under this curve should be half, right? So instead of that you have to multiply it by 2 to get the total area under the curve, right? Right? And what is your equation? It should be 0 to pi by 6, but instead of the waveform we will do like this: root 3 Vm cos omega t overall square multiplied by d omega t. That should be the equation, right? Make sense? Now, what should be the line current value? What should be the line current? IA RMS value. So my IA RMS, what should be the line current RMS value? So now, if I want to take the RMS value, if you square the term, this thing will be positive, right? And if you take the negative square, it will be the positive thing as well, right? Right? So now, suppose we are considering this maximum value to be Im. Suppose this is my Im, maximum value. So what should be the area? What should be the area? Im cos omega t, right? What should be the equation of this curve? Again, suppose you have a curve like this, and this maximum value is Im, and it is starting point is pi by 2. This is 2 pi by 3. So it is happening from 90 degree to 120 degree. So what should be the RMS value then? So it should be square root. What is starting point here? Pi by 3 to 2 pi by 3. So the total length of these things is pi by 3, right? But we are only considering this area. So the total area should be multiplied by 2, right? What is the integration from 0 to pi by 6 or 30 degree, right? So 0 to pi by 6, and then Im square multiplied by what? D omega t. Im cos square omega t multiplied by d omega t, right? What is your Im? What is your Im? If you see here, what is your output voltage? Root 3 Vm, right? And if this voltage is appearing across the load, so the maximum voltage here is root 3 Vm. So what should be the maximum current Im? Root 3 Vm divided by R, right? So here, so what should be your Im then? Im, it should be root 3 Vm divided by R. Make sense? And you know how to do the calculations, right? Now in that case, what your book has done is that instead of doing that, what they did here in your book, they did 0 to pi by 6, and then here they write it down like im square cos square omega t multiplied by d omega t. Now if you take the total length from 0 to 2 pi, so if you divide it by 2 pi, 1 over 2 pi, so how many half cycle you will have within this 2 pi? How many you have like this? 4. And we are considering half of the cycle, right? Introducing this curve. So how many of these will be present within 2 pi? 8, right? So here they multiply it by 8. But this thing and this thing both are same or different? Different?
The area is same, but the area is same.
Same or different?
The area should be same.
Nah.
So if the magnitude is same,
Magnitude is same, but what I am trying to say is that here, if you divide it by the total length, what is the total length here? Pi by 3, right? Pi by 3, right? Okay, so here I just made one mistake. Why this thing will not appear? Because do you have this for the entire thing? But we have here, right? So if you don't have for the entire length, can we take individual length to get the RMS value? It is not continuous, right? So in that case, will this thing applicable? This is applicable for what? Voltage, where the waveform was continuous for between 0 to 2 pi, right? In that case, we can take this value. But for the current, is it continuous or discontinuous? Discontinuous. For that one, we cannot do these things. So in that case, this thing is right, not the previous one. Make sense?
yes, sir.
So similar way, what we can get for diode current then? What will be my diode current? IT1 RMS. What would be my diode current then? As I said, this portion it will not happen, right? Because at that time your D4 will be operating rather than D1. So now, how we can write that equation then? So 0 to pi by 6 Im square cos square omega t multiplied by d omega t. Now what is the length, total length here? 0 to 2 pi. So if I divide it by 0 to 2 pi, how many half circles we will have here? 4. So it will be multiplied by 4. Make sense? So these are the equation which is given directly into your book without any explanation. Okay, but if you know how these things are coming, it will be very easy for you to remember and write it down on the exam paper. Otherwise, if you memorize that one, then it is impossible to write it down correctly in the exam paper. Okay? So you have one example in your Harun Rashid book 3.7. Harun Rashid book 3.7 based on the equation that we have just discussed. So try to do it by yourself, and if you have any question, ask me in the next class. We will discuss on that if you have any problem regarding that. Okay? Any questions so far? Anything? What? Okay, so by doing this math, we have concluded the portion with the uncontrolled rectifier. Now, whatever we will be discussing here is the controlled rectifier one. So, what is the difference between uncontrolled and controlled rectifier? For diode, the turn on and off doesn't depend on the gate pulses, or we don't have any control over it. Whenever your anode voltage is operating at high potential with respect to the cathode voltage, it turns on. But for thyristor, although your anode voltage will be higher than the cathode voltage, no sooner you get the pulses, it will never turn on, right? So suppose you have a electronic circuit that is connected to the inputs by a single phase transformer, that is 1:1 transformer. Sometimes it is called isolation transformer. Isolation transformer. You have heard this name, I think, in the machines class. Sometimes you need a transformer to isolate the load from the input circuit, so that suppose you have any fault at the primary side, it will not have any effect on the load side. Just like when I was child, I used to see a light is connected in series with a TV circuit, so that if some high current flows, the light will get burned down. It will not have any damaging effect on the televisions. Yeah. So for electronic device or very costly device, you cannot use a simple light. Rather, you will use a isolation transformer to protect that device. So now, this configuration, if you redraw that one, it can be rewritten like this. And as you can see here, instead of this load, they put just a simple current source. Why is that? We previously discussed that if you have a highly inductive load, we have shown you the simulation results, right? Do you remember? I have shown the simulation results in the class, right? Using simulating. And as well as we have derived the equation that that tells you that whenever you have a highly inductive load, that what will happen to the current? The current remains constant, right? It will have very less ripples. It will be a flat like a DC current, right? So now, suppose the load is provided by a controllable device now. Instead of 4 diodes, we are using a 4 thyristor circuit. So that's why it is called single phase full converters. Why it is called full converters? We will discuss that later. Okay. So now, for this T1 and T2 or T3 and T4, as long as we are not providing any pulses, what will happen? This thyristor will remain turned off, right? Whenever you give pulses, it will turn on. So what will happen? We are providing a circuit or pulses through a circuit such that it will provide a delay angle to the pulses, or the pulse will be provided to the circuit at a delay angle alpha. So, although during this part your thyristor T1 and T2 is this, for this portion this is plus, this is minus, right? Meaning that your thyristor T1 and T2, it will be operating as soon as you give pulses, right? But we are delaying the pulses by some angle alpha. So in that case, that thyristor T1 and T2 will be turned off until alpha. But when the gate pulses is given at alpha, then what will happen? This T1 and T2, it will be turned on, right? And whenever T1 and T2 is turned on, what will happen? This plus terminal will come across here and the minus terminal it will come across here. So the voltage will appear as like the input, right? So what is the input voltage now? This portion after alpha, so your output will be exactly same as the input. Now, during the negative half cycle, we are delaying the gate pulse alpha for T3 and T4. So from here to here, this point to this point, no pulse is given to T3 and T4. So T3 and T4 will remain off, right? But this is a constant current source and we are achieving that by using a highly inductive load, right? And whenever you have a highly inductive load, what will happen? The inductor doesn't like the current to change through it, right? So, since this is a current source, so what will happen? Until unless T3 and T4 is not turned on, what will happen? This current will flow through T1 all the way through this and then it will go through T2 and go like this, right? So, although during this time this polarities has changed, but T3 and T4 is not turned on. So what will happen? This positive terminal now it will appear across it and this negative terminal it will appear across this, right? Because your T1 and T2 is short circuited, right? So the polarity across the load, will that be positive or negative now? Positive or negative? Negative. So, since T1 and T2 is operating, whenever T1 and T2 is operating, whatever is the input voltage that will appear across the output, right? So, from here to here, the input voltage is what? Negative. So, the output voltage will be negative as well, right? Until unless you provide a pulse to T3 and T4. When this T3 and T4 operates, then what will happen? Again, then T1 and T2 will be turned off and then T3 and T4 will be turned on. So what will happen now? The current will start flowing through this way and then it will come back through like this. Right? So now what will happen to the output? Is it positive now or negative?
Positive.
Again positive, right? Why it is again positive? Because now you can see, since this is short circuited, this positive terminal it will appear here, and since this is short circuited, so this negative terminal it will appear here, right? Now you got your answer, right? How it is becoming negative or positive once you have the negative thing. So again, then it will be positive. So this entire section here, it will be flipped across the output and you will see the exact image of that one, right? And similar to that one, until unless you have a 0 to alpha, we are delaying it by 0 to alpha for the positive half cycle, right? Where we are not providing any pulses to where? T1 and T2, right? So what will happen? T3 and T4, it will start conducting until unless T1 and T2 is turned on, right? So whenever from this part to this part, what is happening? The polarities is again changed, right? The polarity is again changed, right? So now the polarity is like this. This is positive, this is negative, right? So what will happen to the output?
It's negative.
What will happen to the output?
Negative.
Negative.
Since this is short circuited, then what will happen? This negative terminal, it will appear here, right? And this terminal is positive, meaning that this terminal will be positive as well. So what will be the polarities across the output?
Negative.
Negative, right? So that's why you have a negative here as well as negative here.
So negative portion what you are
Yeah, sure. So now we will consider this. For example, you have a simple this sinusoidal waveform. Okay? So what we are doing here? We are dealing the pulses by angle alpha, right? So similarly, we are dealing from here to here alpha, right? So now from this time on, this portion, what is happening? T1 and T2, they are turned off, right? T1 and T2 is turned off. So in that case, which are the thyristor that is operating? T3 and T4. So if T3 and T4 is operating, T3 and T4 is operating, what is the polarities across the source? It is positive, right? Meaning the polarity should be this is positive, this is negative, right? So this is negative means what? Through the T3, what should be the polarities there? Negative. Right? And this positive polarities means this terminal is positive, right? And this terminal through that T4, it is shorted, so this terminal, it should be positive, right? No, because the thyristor, although the voltage across is reverse bias, that the current is flowing, right? So it will remain turned on. Because this inductor here, it is forcing that thyristor to remain turned on. Make sense? So if in this case, what is the polarities across the load? Is it positive or negative? Negative. That's why it is negative up to when the T1 and T2 starts operating. Make sense? Any question? Any question? You understood how these things happening, right? So now, both cases, when this is the positive polarities, what will happen to the current direction? So when T1 and T2 is operating, what is the current direction? These two are operating. So what is the current direction here? This way, right? This way, right? Now when T1 and T2 is turned off, but T3 and T4 is turned on. What is the direction of the current? Same, right? Same, right? So that's why your load current here, it is constant DC current. Make sense? But when T1 and T2 is turned on, T1 and T2 is turned on, T1 and T2 is turned on, T1 and T2 is turned on. What is the source current now? In this direction, right? And it is coming back through this in this direction, right? Right? So if this direction is positive, so when T1 and T2 is operating, the current direction is positive, right? Because T1 and T2 is operating from this point to this point, right? Now what will happen when T3 and T4 starts operating? So what will happen? So as soon as T1 and T2 is turned off and T3 and T4 is turned on, T3 and T4 is turned on. So what will be the direction of the current? So polarities of that, it will change, right? Negative, this should be positive. So what should be the direction of the current? This way, it will go like this, and then it will come back like this, and then it will go like this, right? So direction of the current will be changed, or it will be unidirectional? It will be changed, right? Input current, we are not talking about the load current. Input current will be changed, right? Although the load current it will be constant DC. So whenever T1 and T2 is operating, the current will be in one direction. Whenever T3 and T4 is operating, the current will be in the opposite direction, right? Make sense? So we will conclude our class today here. I will request you all to go through that lecture that we have we discussed in this class, and if you have any question, just ask me in the next class, and we will do some maths based on this theory in the next class also. So stay here. Since on Friday we will not have any class, so can we do one class on Saturday or Sunday online? Okay. It could be A section or C section. Okay. Can I have the attendance?